angles or metal cutting. So remember this, tan theta equal to r cos alpha by 1 minus r sin alpha. So याद रखिए इसको, अगर याद नहीं याद रखो, और एज वेल एज डेरिवेशन भी पूछ सकते हैं आपको एग्जाम में. अगर आप एग्जामिनेशन पॉइंट ऑफ व्यू अगर पढ़ रहे हो तो डेफिनेटली, क्योंकि अगर 5 मार्क इवन 10 मार्क का भी दे सकते हैं, राइट. So be careful for this derivation. So then what we'll do, so we'll take one small problem so that it can be easy for you to remember. So one small problem is there. So this is nothing but theta is shear angle, right? So importance of shear angle, those things you can see after this. So just because once we derive the one formula, so just we'll see one problem. So in an orthogonal machining, so whatever the machining we've seen, last class we've seen about the classification of machining process also. So orthogonal machining or orthogonal cutting and oblique cutting, right? Oblique machining. So what is orthogonal cutting? So there is a question is there in front of you. In an orthogonal machining, cutting tool having a rake angle. Rake angle means back rake angle. Rake angle of 12 degrees. Depth of cut being 0.18 mm. And chip thickness is measured to be 0.44 mm. So determine the shear plane angle. Right? So previous formula, whatever we discussed, tan theta equal to r sin alpha 1 by cos alpha, r cos alpha by 1 minus r sin alpha. So this formula used by that formula, we need to find the shear angle, right? Simple hai na? So isme what is mean by orthogonal machining? Orthogonal machining are nothing but orthogonal cutting, right? Machining process we have seen, right? Cutting, machining or metal removal is the same synonyms, same thing only for this subject. So what is meant by orthogonal machining? Last class we discussed this also. Please pay attention.
Which is mutually perpendicular.
Yes. So there is two different processes we have seen: orthogonal cutting and oblique cutting. If cutting edge, so whatever the cutting edge, for example, this is समझिए ये छुरी है या फिर ये कटर है. So this cutting edge angle is moving perpendicular. The velocity or direction of motion is perpendicular to the cutting edge. That is calling it as a orthogonal cutting. तो जो हम इसमें देख रहे हैं orthogonal cutting. और एक cutting है oblique cutting. Oblique cutting किसको बोलते हैं? Instead of vertical, अब maybe see my video में मैं जो दिख रहा हूँ ना, मेरे को देखिए. तो फॉर एग्जाम्पल ये दिस इज मेरा ये जो हाथ दिख रहा है, जस्ट अज्यूम दिस एज ए कटिंग एज. ये कटिंग एज अगर जो आपका कटिंग टू वर्कपीस मटेरियल है उसको परपेंडिकुलर रहा तो दैट इज कॉल्ड एज ए ऑर्थोगोनल कटिंग. मींस योर द कटिंग टूल इज मूविंग परपेंडिकुलर टू द एज. इफ इट इज नॉट मूविंग परपेंडिकुलर, ऐसा काटने के बदले में भी थोड़ा सा टर्न कर लिया, थोड़ा इंक्लिनेशन दिए, तो मे बी इंस्टेड ऑफ 90 degrees we are giving something like 75 degrees or maybe 70 degrees or maybe 30 degrees, some angle if you're giving. So this kind of cutting is called as a oblique cutting, right? So where that cutting edge, whatever a cutting edge as well as the direction on which it is moving, it is not perpendicular. So other than perpendicular, if anything is there, that we used to call as a oblique cutting. If something is perpendicular, is considered as a orthogonal cutting. So for our mathematics simplicity, we are assuming, so whatever the cutting edge is there, it is moving perpendicular. So जो whatever the cutting edge is there, अगर ये cutting edge है आप समझ रहे, तो ये अगर समझिए आप ये cutter है, right? So this is a pen. So this is a cutter, right? Just sharp edge समझिए इसको. So this is moving perpendicular to the workpiece, or maybe it's moving perpendicular to this edge. Then this cutting is considered as a orthogonal cutting. Or this orthogonal cutting we also called as a two-dimensional cutting. Yes, last class we have seen. So two-dimensional, why? Because we want only two dimensions are sufficient. One is edge, cutting edge, and one is the direction of motion. That is sufficient. But if it is an incline in oblique cutting, so then this whatever the edges are there, we need to resolve in the two mutual perpendicular direction, right? One direction is coming perpendicular in this direction, one is in this direction. Means from cutting edge itself, we are going to get two resolving forces and one the moving direction. So we are getting three directions. That's why we used to call it as 3D cutting. So oblique cutting is considering as a 3D cutting and orthogonal cutting is considering as a 2D cutting. So for our mathematical simplification in this complete your subject, we are considering all cuttings are orthogonal cutting. We're not bothering about oblique cutting, right? So in this problem, whatever is there, one orthogonal machining or cutting is happening where tool rake angle is 12 degrees, depth of cut. So I told you depth of cut is nothing but whatever the material is advanced, whatever the layer of material is removing. So that layer of material is 0.018 mm, right? And after machining, once layer of material is removed, chip is coming out from the workpiece. That thickness of the chip is 0.44 mm, right? So these three parameters are given and asking you to determine the shear plane angle, right? So how to find this? Very simple, right? Whatever we have seen in previous problem, previous formula is simple. You need to you need to submit in that formula, right? So, but always when you're writing an exam, how to write, I think most of the people know that, but still I am repeating again. So any numerical problem is coming, whether it's from MMT, whether it's a design of machine member, whether it's a operational research or whatever. So any problem, if you're coming, you need to write neatly in the exam so that examiner will impress with your answers, right? Whatever the things you're writing, he need to feel comfortable to correction. If you feel comfortable in correction, he will give you more marks. Yaad rakho. So if you're paining the examiner, something you're writing somewhere in the answer paper, then definitely the examiner will lose his mind, right? He will very difficultly he will search your answer. So then getting your marks are less. Remember this. Whatever the exam, that's why we used to tell that whatever the exam you're writing, you need to write properly, legibly. So whatever you're writing, examiner can read. So readable आप लिख रहे हो तो definitely, because if you're writing properly, you're writing neatly, then definitely you're getting even whatever marks you're deserving. Even examiner will give you 1 mark more. For example, your question is 10 marks. You written some derivation, you have done some picture, something, which is maybe if 1 or 2 steps is gone wrong, but finally you're getting answer correct. Even sometimes because of numerical correction error, maybe you're getting answer also less. Other wrong answer or different answer you'll get. So what happened? So as per the procedure of evaluation procedure, they will reduce your marks. 10 marks का question रहा, question 10 marks का है. So if your answer is perfectly correct, step by step is correct, maybe you're getting 10 out of 10. If it is not perfectly correct, somewhere steps are missing or somewhere answer finally numerical answer is coming wrong, so you're not going to get 0. You're getting some marks for your steps, right? So in that case, for example, your some steps are wrong, maybe out of 10, maybe you're deserving 5 marks. But if you write properly, so instead of 5 marks, examiner will give you 6 marks, maybe 7 marks also. So you're getting 1 or 2 marks more than whatever you marks deserve. So please write your exam properly. So पढ़ना समझना जरूरी है, साथ में लिखना भी बहुत जरूरी है. So whatever the exam you're writing, so you need to write it properly, right? So this kind of question, if anything is coming, first you need to give the whatever the given data is there in the question, so that you need to write down. So what is the given data is there in that? So given clearly, cutting tool having a rake angle of 12 degrees. So rake angle is given, and one more thing is given, depth of cut, right? Depth of cut is given, which is depth of cut is nothing but 0.18. So depth of cut in our calculations we're considering as T1 is the depth of cut, and similarly rake angle is alpha. So alpha given as 12 degrees, and T1 thickness of depth of cut is nothing but uncut chip thickness. So uncut chip thickness or depth of cut, the meaning is same. So T1 is given as 0.18, and then chip thickness. So chip thickness is nothing but whatever the chip is there, the thickness is T2. So T2 is given as how much? 0.44 mm, right? So these are the 3 parameters given in your question. And what is asking? What is asking to find? Given data is 3 parameters and asking you the 1 parameter, that is shear plane angle, right? So you need to mention whenever you're writing an exam, please write in this way, and then you need to have your solution. So even if you're not mentioned, solution is not a problem. Then you can start your steps. So how need to find a solution now? Because just now we have seen, right? Last class end, and just now also I discussed, there is a formula is there for tan theta, because they're asking about determine the shear plane angle. So theta is the shear plane angle, right? So theta is, we need to find the theta. So what is the formula is there? Tan theta equal to R cos alpha divided by 1 minus R sin alpha, right? So just simply you need to substitute the values in this, you're going to get your answer. So even in exam, this may come for 2 marks also. This may come for the 5 marks also, right? So as I told you, based upon your marks, your answers has to be there. Your solution or your whatever you're writing is accordingly you need to write. तो 2 मार्क्स के क्वेश्चन को 5 मार्क के क्वेश्चन को आप एक जैसा आंसर नहीं लिखना चाहिए, याद रखिए. अगर 2 मार्क का दिए तो बस सिंपल जो आप ये बता रहे ना, इवन गिवन डेटा वो नहीं भी लिखे तो चल जाता. तो डायरेक्टली यू कैन राइट द सॉल्यूशन, write it theta equal to R cos alpha 1 minus R sin alpha. So in that you substitute the values, whatever the theta is there, you're going to get 2 marks. But if it is a 5 marks, definitely you need to mention all these things. You need to give the given data, you need to give what need to give and find it, and then you need to give the solution, and solution also you need to give a detailed solution you need to give. I mean, in this you need to have 2 methods to write, right? So one, directly you can substitute R. You know R is nothing but thickness ratio, right? T1 by T2. So directly you can write T1 by T2 instead of R, T1 by T2 cos alpha. Alpha is nothing but 12 degrees. T1 is 0.18 and T2 is 0.044. So directly 0.18 divided by 0.44 into cos 12 degrees divided by 1 minus again 0.18 divided by 0.44 sin 12 degrees. ये एक स्टेप डाल दो, उसके अंदर आप कैलकुलेट कर लो, आंसर डाल दो, खत्म हो गया. 2 मार्क्स का क्वेश्चन, एक फार्मूला, उसके बाद में उसके फार्मूला में वैल्यू सब्स्टिट्यूट कर रहे, उसके बाद में फाइनली आंसर आ रहा. बस 3 स्टेप्स में आपका आपका आंसर हो गया, तो यू आर गेटिंग 2 मार्क्स, राइट? सेम का आंसर अगर आप करेंगे, सेम क्वेश्चन है, 5 मार्क को वही क्वेश्चन पूछा, यू डूइंग द सेम थिंग, so for 3 steps are you expecting 5 marks? Yes, you're expecting 5 marks for 3 steps, but examiner will check 3 steps 5 marks, your answer is correct, your method is correct, everything is correct, but your expression, presentation is whatever you are presenting in the answer paper, it is not up to deserving for the 5 marks. तो याद रखिए, आपका आंसर करेक्ट है, आपको सब आता, मालूम है सबको, इवन एग्जामिनर देखने वाले को मालूम है आता, बट क्योंकि ओनली 2 स्टेप 3 स्टेप में रखे, तो आपका 5 मार्क्स के क्वेश्चन को वो 2 या 3 मार्क्स या 2 मार्क्स या फिर 4 मार्क्स दे सकता, 1 मार्क हो सकता कट करे। अगर अगर अच्छा एग्जाम इन्विजिलेटर है, ये ठीक है, सब स्टेप्स तो बराबर है, करे तो दे सकता 5, बट डोंट एक्सपेक्ट दैट। तो अगर आपको 5 मार्क एक्सपेक्ट करें तो यू नीड टू राइट द आंसर इन दिस वे, राइट? तो मैं क्या कर रहा हूँ इसमें, आई एम सॉल्विंग इट फॉर द 5 मार्क्स क्वेश्चन, आई एम नॉट सॉल्विंग फॉर द 2 मार्क्स क्वेश्चन। So next unit, in this unknown factor is there, because you see in the given data you know alpha, right? So you don't know r value, right? First what you need to do, you need to find the r value. So first आप r का फार्मूला ले लो। So what is r value? R value is nothing but it's a thickness ratio, chip thickness ratio, otherwise it's nothing but your machining ratio. So T1 by T2, so r is equal to T1 by T2, so T1 how much? 0.18, T2 is 0.44, so this is coming to be 0.41, so r value is coming from 0.41. so ऐसा स्टेप डाला तो ये स्टेप को, this calculation is going to get you 1 marks या 2 marks, right? तो हो सकता है इसको 2 marks, क्योंकि whenever the evolution is happening, जब भी हम लोग जब पेपर करेक्शन करने जाते तो हमारे को एवोल्यूशन की स्कीम मिलती, राइट? तो हर उसमें इवन तो आपको 5 मार्क है, तो 5 मार्क डायरेक्टली नीचे 5 मार्क नहीं देते, आंसर को डायरेक्टली 5 मार्क नहीं मिलता, क्योंकि किसी बच्चे का आंसर करेक्ट हुआ तो we are not going to give him 0 marks, right? We need to give some marks for his steps, so whatever explanation is written, for that we need to give the marks. So clearly evolution scheme used to given to us, so उसमें evolution scheme में step by step को मार्क रहते। अगर नॉर्मल 2 क्वेश्चन डायरेक्टली आंसर रहता, राइट? डायरेक्ट आंसर रहता, फार्मूला डाल देते, डायरेक्ट आंसर देते, ये आ रहा, तो वो आया तो 2 को 2 दे दो, मैं खाली फार्मूला लिखे बच्चे, अगर आंसर न्यूमेरिकल निकाल कर, तो इंस्टेड ऑफ गिविंग 2 they'll give 1 mark, right? So this will happen, but if you're going for 5 marks or 10 marks, each step carrying marks, तो ये याद रखिए आप। आई थिंक बिकॉज ऑफ दिस यू आर लूजिंग सम मार्क्स। तो आप मे भी सोचते, जब एग्जाम लिख के आने के बाद आप सोचते हैं मैं पास हो जाता, मेरे को मिनिमम 26 मार्क्स आते, मिनिमम 30 मार्क्स आएंगे, 40 आएंगे, 50 आएंगे सोचते, बट व्हेन रिजल्ट हैज कम, सो यू विल गोइंग टू लूज द मार्क्स, इंस्टेड ऑफ 40, इंस्टेड ऑफ 50 यू आर गोइंग टू गेट 35 और मे बी 45, और मे बी इन सम स्टूडेंट्स कंडीशंस 30 मार्क्स के आपको 25 आ जाते, तो यू आर एक्सपेक्टिंग 30 बट अनफॉर्चुनेटली यू गॉट 25 एंड यू फेल्ड इन द सब्जेक्ट। तो ऐसा होता। So to avoid those things, whatever the 3 hours time is given to you, you need to maximum utilize the time. 3 घंटे का टाइम आपको ऐसी नहीं चाहिए, याद रखिए आप। कोई बच्चे 1 घंटा में लिख के चले आ रहा, 1.5 घंटे में लिख के चले आ रहा, मे बी you're writing full, you're a good student, but if you're going 1.5 hour means, so whatever the mark scheme is given, in that you're not justifying somewhere. So please careful, आज के बाद से कौन सा भी डिस्क्रिप्टिव एग्जाम जो लिख रहे हो आप लोग, तो प्लीज फोकस इन दिस वे, यू नीड टू राइट एग्जाम इन प्रॉपरली। आपका मेथड करेक्ट है, आपको सब आता, इसमें क्वेश्चन नहीं है, बट आपका राइटिंग जो है ना, उसमें जो स्कीम, मार्क एवोल्यूशन स्कीम है, वो एवोल्यूशन स्कीम को प्रॉपरली आप डिफाइन करो, वहां पर आपको फुल मार्क आता। तो नहीं लिखे 2 स्टेप में भी डाले तो आपको मार्क आ सकते, बट एवोल्यूटर पे डिपेंड करता। तो एवोल्यूटर बोल सकता है सर ये स्टेप नहीं है आपके पता, इवन आप कल रिवैल्यूएशन को कल डाले, या फिर फोर्स रिवैल्यूएशन भी डाले, जिसमें आपके फैकल्टी भी वहां रहते हैं जाके चेक करने में। तो जब आप हम अगर फॉर एग्जांपल कल एमएमटी में आप जाके रहेंगे, एक क्वेश्चन आएगा, आप लिखेंगे तो बस 2 स्टेप में लिख देंगे 5 मार्क का, मैं जाके वहां आपके बिहाफ ऑफ में भी मैं एवोल्यूशन करूंगा, तो जो जेएनटीयू के एवोल्यूटर रहते हैं वो यही बोलेंगे सर ये स्टेप मिस हुआ, सो हाउ दिस 2 marks has gone, so instead of 5 marks evaluator has given 3 marks only, so his answer is correct but steps are missing, so maybe he's copied somewhere, so these doubts भी आ सकते हैं ना। तो इसलिए so whatever the answer you're writing, please write it properly. So first you need to find r value. Now get the r value is 0.41. अब देखिए फार्मूला क्या है, r cos alpha 1 minus r sin alpha. R values we know. Now you substitute this r value and then do it. Tan theta equal to, now whatever the formula I have given, tan theta equal to r, in that I am substituting now. Tan theta equal to 0.41 cos 12 divided by 1 minus 41 sin 12. So when you substituting this and when you calculating in your calculator, you're going to get how much? 0.4383. So please calculate this. So calculate करके बोलिए वैल्यू करेक्ट है नहीं है। तो याद रखिए whatever the values I am keeping on the slide, sometimes mistake also may happen. तो एक टाइम हो सकता है मेरे से कैलकुलेशन में मिस्टेक हो, या कभी कभी इंटेंशनली मैं रॉन्ग वैल्यू भी रखूंगा। तो इसीलिए जो whatever the values I am giving in the slides, तो don't trust 100%। अभी बोल रहा हूँ मैं 100% ट्रस्ट मत करिए उस पर, आप भी एक बार कैलकुलेट करिए। That's why I told you, keep your class notes, keep your calculator, and then you just do it. So ये कैलकुलेट करिए, कैलकुलेट में कुछ आंसर बोलिए, दिस इज नॉट द फाइनल आंसर, दिस ओनली tan theta।
43841
ओके, ठीक है ठीक है, मैं अप्रोक्सीमेटली मतलब हो सकता है मेरे उसमें भी कोई वैल्यूज में राउंड फिगर कर दिया हूँ, लास्ट 12 का वैल्यू सेपरेट कैलकुलेट कराऊंगा, दैट्स फाइन। 438
सर वो 0.18 बाई 0.004 की वैल्यू आप 41 लिए ना, 0.41 लिए,
जी
4090 आ रही है
हाँ
अप्रोक्सीमेटली।
4090, यस यस, वहां पर मैं राउंड कर दिया हूँ, इसलिए यहाँ पर भी ये फिगर थोड़ा डिफरेंस हुआ, राइट। तो दिस देखो 1-2% अगर न्यूमेरिकल एरर है तो प्रॉब्लम नहीं है, क्लोज आया तो बस से। तो इसका टैन वैल्यू कितना है बताइए मेरे को, tan theta equal to 0.4383. Now we need, actually question is asking shear angle, so this is not the shear angle, this is only tan theta. Now shear angle is theta, so theta equal to tan inverse, so whatever the values we need to give, so that is coming something about 23.668 with this, so 4383 आया तो ये आ रहा, so आपको में भी जो दूसरा आया तो में भी आपको हो सकता है 23.667 आए, या फिर हो सकता 23.669 या कुछ आ सकता है।
यस सर 67
6-7 आ रहा, ओके फाइन, 6-7 आर 6-6 इज इट ओके, इवन मेरा माई भी राउंड फिगर राउंड उसको वेज कर दे रहा हूं मैं 23.67, तो क्योंकि 668 नॉर्मली हम लोग एंगल जो भी डिसाइन करते हैं ओनली विल गिव 2 डेसिमल पॉइंट्स ओनली, राइट, सो इंस्टेड ऑफ 668 because 8 is more than 5, so we can round up to 67, so for to me is coming 23.67 is the answer, right. So simple question, so this is we may ask for 2 marks also, actually 2 marks का क्वेश्चन है, फार्मूला लिखो, फार्मूला सब्स्टिट्यूट कर दो, आपको मार्क आ जाते हैं, बट मैं इसको 5 मार्क क्वेश्चन के जैसा सॉल्व कर रहा हूं यहाँ पर, क्योंकि यू सी सॉल्यूशन आई एम गिविंग 5 स्टेप्स, so there is no scope for the examiner to remove the cut mark in anywhere, तो 5 स्टेप का है, 5 मार्क देना ही है उसको, अगर उन्हें नहीं दिया, उन्हें आप फिर रिवैल्यूएशन करे तो आप भी, आपके भी ऑफ जो भी जाएंगे वो लोग क्वेश्चन कर सकते, तो आंसर करेक्ट है, स्टेप्स पूरा क्लियर है, एक्सप्लेनेशन बराबर है, व्हाई इज कटिंग इवन फॉर 1 मार्क, इवन ही नॉट, एग्जामिनर मे नॉट कट इवन, अगर 5 मार्क का क्वेश्चन है तो डेफिनेटली ही नीड टू गिव द 5 मार्क्स। अलबत्ता यही क्वेश्चन अगर 10 मार्क को पूछे तो सेम क्वेश्चन है, 2 मार्क भी पूछ सकते हैं, आप डायरेक्टली फर्स्ट स्टेप डालो, लास्ट स्टेप डाल दो, बस खत्म, राइट, आंसर आ जा रहा। अगर 5 मार्क को डाल रहे हैं तो ऐसा एक्सप्लेन करो, आप कोई 10 मार्क को डाल रहे हैं, कैसा करना, सेम क्वेश्चन है, एक ही पैरामीटर पूछा, नॉर्मली 10 मार्क के क्वेश्चन है 2-3 पैरामीटर पूछते, तो एक एक का एक स्टेप रहता, एक स्टेप रहता, बट कभी भी 10 मार्क का आपको दे रहे तो इन एडिशन टू दिस यू नीड टू ड्रा द एंगल्स आल्सो, तो यहाँ पर एक पिक्चर उतार दो कटिंग टूल का, एक कटिंग टूल का पिक्चर इधर उतार के उसके अल्फा क्या है, टीटा क्या है, सो आई टोल्ड यू इफ इट इज द 10 मार्क्स, सो हाउ टू राइट, सो ये स्टेप तो सेम रहेंगे, राइट, सेम रहेंगे, उसके अलावा मे बी यू कैन ड्रा वन इमेज हियर, तो लाइक इससे पहले के स्लाइड में जो था ना, तो ऐसा दिस इज वन वर्क पीस मटेरियल, here you have a cutting tool, right, you have a cutting tool here, right, तो इसके अंदर अल्फा क्या है इसमें, तो दिस इज अल्फा, जस्ट मेंशन इट, क्योंकि मैं माउस से लिख रहा हूं, इसे क्लैरिटी ठीक नहीं आ रही है, सो दिस इज नथिंग बट अल्फा, एंड दिस इज योर shear plane angle, right, so this is nothing but theta, so these things you need to show it here, अगर 10 मार्क का रहे तो इवन उसमें एक नहीं, 1 से 2 से 3 या 4 पैरामीटर भी पूछे, अगर 10 मार्क का है तो यू कैन ड्रा ए नीट स्केच, जस्ट रफ स्केच, नीट स्केच, रफ स्केच का ड्रा करो, कुछ उसमें ऐसा नहीं बोल रहा हूँ कि एक परफेक्ट एक 3D एक अच्छी खासी पिक्चर, जबरदस्त पिक्चर उतारो बोल के नहीं बोल रहा हूँ मैं, बट एक रफ स्केच, बट नीट है ना स्केच, इट्स नॉट लाइक दैट सम लाइंस आर क्रॉस लाइंस आर कमिंग, वैसा नहीं, अब जैसा उतारो मैं ऐसा नहीं उतारना, क्योंकि इसमें उतार रहा हूँ मैं, इसलिए मुझे प्रॉपर्ली आ नहीं रहा है, मैं बस आपको एक रफ बता रहा हूँ, you draw a line here, you can show it alpha, this is showing as the theta, and here you can show it as the t1, and whatever the chip is coming, right, so this is tool and this is chip, right, so इसको थोड़ा इसको वो कर दो, and this is your t2, right, so this is the t1, right, so this is the t1 and this is t2, so whatever things are there, this is t2, तो आप ऐसा करें तो आपके 10 मार्क कोई भी कट नहीं कर सकता, तो इसमें ये पिक्चर के लिए 2 से 3 मार्क दे देता हो, 5 स्टेप को 5 मार्क है, 7-8 मार्क आ गए, और गिवन डेटा एंड क्वेश्चन डेटा दे दिया उसको 2 मार्क्स, so you're going to get 10 marks. If it is a 5 marks, if you are giving this, nobody will cut your even a single mark. तो 5 मार्क का क्वेश्चन है तो 5 मार्क आते, 10 मार्क का क्वेश्चन ऐसा रखे आप तो 10 मार्क आते। फॉर एग्जांपल आप 10 मार्क के क्वेश्चन को खाली स्टेप्स, डिटेल स्टेप्स डाल दिए, इमेज नहीं उतारे, तो क्या करता है एग्जामिनर, बोलता है वो इमेज के वास्ते 1 मार्क या 2 मार्क या 3 मार्क कट कर सकता, मतलब यू विल गेटिंग 7 marks or 8 marks or maybe 9 marks also, because your explanation everything is perfect, but unfortunately you not drawn the sketch because you are forgotten, or maybe आपके पास पेंसिल नहीं थी, और पेंसिल है तो पेन से ड्रा करो, रफली रफ स्केच ड्रा करो, ऐसा नहीं कि आपको आर्टिस्ट के साथ ड्रा करने की जरूरत नहीं है, जस्ट रफ स्केच है, इंजीनियर कैसे लाइन से जो ड्रा करते हैं बस उस तरीके से ड्रा करना है। तो अब वो ड्रा करने के बाद आप अगर कोई क्वेश्चन अगर आंसर नहीं उसका अगर मार्क्स नहीं मिले आपको, यू कैन आस्क हिम, you can claim also, right, so please your answers has to be as per the question, right, ठीक है, I think note down, can we go for next slide? So I'm giving you 1 minute time. Please note down this question as well as this one. So this derivation as well as this question is not there in your textbook. So textbook, whatever I told you, this is only for your study. So in that, whatever I am teaching, sometimes maybe if some information is not sufficient in the textbook, maybe I will refer to other textbooks also. So whatever this is there, I have taken from this book. So जो मैं बोला हूँ ना मैं, मैन्युफैक्चरिंग टेक्नोलॉजी बाय R.K. राजपूत, ये बुक से लिया हूँ मैं, ये प्रॉब्लम, ये बुक का प्रॉब्लम. Because when we faculty, when we are doing something, some information is not sufficient in one book, we need to take from other book. That is every faculty used to follow. Even sometimes if not available, we'll go for Google also. So, right, we can go for next slide.
Yes, sir.
Okay. So please ऐसे क्वेश्चन आ सकते हैं एग्जाम में. तो जो न्यूमेरिकल प्रॉब्लम आप बोले थे, पूछे थे ना फर्स्ट क्लास में, सर ये थ्योरी सब्जेक्ट है या प्रॉब्लमेटिक सब्जेक्ट है. Definitely it's a theoretical subject only. So still in that 10 to 15% problems also may be there. Problems as well as the derivations. So now we'll see what is the importance of shear plane angle. So shear plane angle, if it is a shear plane angle is bigger, you will resulting in the less high shear stress. Shear stress effects of higher shear plane angle. If shear plane angle is increases, your shear stresses are decreasing. So shear angle and its significance, effect of higher shear plane angle. Higher shear plane angle means smaller the shear plane. So if angle बढ़ रहा है, whatever is there, so whatever here there, actually this is theta, it's not phi. Some textbook is mentioning as phi also. So this is actually a theta, right? So theta is the shear plane angle. So if the shear plane angle is increases, so you just see whatever your shear plane is there. So shear plane is nothing but last class we have seen, right? Problem. Just I am drawing it as A and B line, right? So this AB line is nothing but shear plane. So if its angle is less, assume it, जितना कम होते जाएगा shear plane angle, so your shear plane size is that much increasing. So higher the shear plane angle means smaller the shear plane, means lower the shear plane angle means higher the bigger or larger the shear plane, which means lower shear forces. As area is decreases, so obviously shear force is decreasing. Shear force decreases, cutting forces required for cutting forces are decreased. As the cutting forces decrease, definitely power requirement is coming down. So as power requirement is coming down, yesterday we have seen the heat is generating, whatever the power we are supplying, in that 98% of the energy is converting into heat. So you are supplying less power, so obviously temperature increasing also is decreasing. So always we need to make sure we need to go for high to high shear angle. So यहाँ पर एक क्वेश्चन अब रेज होगा. So how the shear plane angle if increases, how the area is decreasing? Simple question. यहाँ पर दो है देखिए. So here one image is there, here one image is there. So in this, if see, so which having higher angle? So first उसमें A में angle has बढ़ के है, B में angle बढ़ के है. So obviously A में बढ़ के है, right? So A angle is more than B angle, right? So you see here, if it is A angle is more, so then whatever the length of this line is less than length of this line. This line length is higher because its angle is less. So because of this angle is less, your length is more. Here angle is higher, this length is less. Simple. उसमें क्या है, how it is, just assume this is your material, right? So this is your material and this is your cutting surface, right? So if it is a shear plane angle is smaller, this angle, so this line is going to cut at this particular point, right? So your thickness is nothing but this much is your thickness. So chip thickness is this much. If your angle is little bit higher, so instead of 5, maybe I can making that like this. So इतना angle बड़ा है, हो गया. तो क्या हो गया आपका? So आपका actually raw material का जो surface है, that is here only. So whatever the raw material surface is there, that is here itself. Then you see your length of, so whatever the length of your shear plane is there, this is up to here. इतना ही हो गया. तो और चिप क्या हो गया आपका? चिप यहीं से आना शुरू हो गया. मतलब आपका चिप का thickness कम हो रहा. So as angle, shear plane angle is increases, your chip thickness, uncut or cut chip thickness is decreasing. So as chip thickness is decreasing, why? Because your shear plane size, length of the shear plane is decreasing. As length of the shear plane is decreasing the force, cutting force, decreasing the power, decreasing the temperature. So that is the best condition. That's why we need to make sure that we need to have as much shear force as shear plane size as possible, and angle as high as possible, and length as less as possible. So what to do for this, right? So क्या करना चाहिए फिर उसके लिए, right? So यहाँ जाइए अब. Shear angle is significant. So shear angle is the angle made by the shear plane with the cutting speed vector. So nothing but this is cutting speed vector here, na? Yeah. This is your cutting speed, right? So your cutting tool is moving in this direction. So this direction, this whatever the shear plane is there, that is making an angle. So shear angle is nothing but angle made by the shear plane. So shear plane is nothing but from where material is deforming. So shear plane with the direction of velocity or direction of your cutting tool. So this is your angle of shear plane angle, right? So shear angle is very important parameter to material to metal cutting. So I just now previously whatever I shown you, as the shear plane angle is increases, so shear plane size is decreasing, your force, power, temperature, everything is decreasing. So our intention is we need to cut the material with less force, with less consumption of power, with less increasing of temperature, right? So all these things are required. So for that we need to go for higher angle. So but we cannot go for more higher angle. If more higher angle is coming, again some other problem will happen. Your tool life will come down, your tool wear is happen, those things are happen. So for this, how we can control this theta value, how we can increase this theta value, right? How we can increase the theta value? The metal cutting is observed that higher the rake angle give rise to the higher shear angle. So high shear angle चाहिए तो क्या करना है? Rake angle. Shear angle अपने हाथ में नहीं. We cannot control shear angle, right? It is happening during the deformation. We are not giving. So but shear angle is depending upon the rake angle. But rake angle we can give. So tan theta is nothing but r cos alpha by 1 minus r sin alpha. Just now we have seen the formula. Assume if r value is increases, right? So definitely this theta value also will increase, right? Here r value increases, this value increases, as well as this value decreases. So because 1 minus r sin alpha, क्योंकि न्यूमरेटर बढ़ रहा और डिनोमिनेटर घट रहा, तो ऑब्वियसली आपका जो वैल्यू है, जो फाइनल वैल्यू आता, डेफिनेटली वो बढ़ जाता. So as alpha values increases, is nothing but rake angle is increasing, your shear angle is increasing. As shear angle is increases, your shear plane length is decreasing. As shear plane length is decreasing, your force, power, temperature, everything is decreasing, right? So with same power, we can do more machining, more cutting can be happened if you're having a less angle, right? So we having a अपने पास lathe machine है, जिस capacity of 5 kilowatt, right? अगर हम proper angle देंगे, angle ज़्यादा से ज़्यादा देंगे, तो power consumption तो है, that is come down. So whatever the 5 kilowatt power is there, instead of 5 kilowatt, you can same machining will cut within the 3 kilowatt. So in 5 kilowatt, we can machine more surface or more material we can cut. So this is one of the important parameter in whenever designing or whenever manufacturing. That कम से कम आप क्या alpha value ज़्यादा से ज़्यादा रखे, तो क्योंकि rake angle already we have seen single point geometry of single point cutting tool, right? So rake angle is nothing but the angle to whatever your cutting surface, cutting face is doing with the vertical plane. If this angle is more, तो अगर ये angle बढ़ते जाएगा, alpha value बढ़ते जाएगा, so then your theta value also is increasing. As theta value increasing, so all the benefits what we just discussed, power reduction, heat temperature decreased, right? Temperature generation is less, force applying is less. All these things will happen. So that's why rake angle is very important in any cutting tool. So you need to keep rake angle as much as possible. But if you're going for more higher rake angle, what happened? Your tool strength is decreases. So इसलिए हम rake angle इतना भी नहीं रख सकते. For example, rake angle 90 कर दिए, तो आपका tan theta value बहुत क्या बोलता है? Theta value is coming more, right? But that we cannot do, right? So that thing will weaken your tool. So alpha value का एक limit रहता, so उसके limit से beyond हम alpha value को नहीं रख सकते, right? So alpha value, then you having a theta based upon alpha value, or theta value is coming. So theta value is governed by the alpha value. That's why your rake angle in any cutting tool, whether it's a milling cutter, whether it's a turning cutter, or any cutter, alpha value or nothing but rake angle is the more important parameter. So याद रखिए इसको. So then coming to the other parameters which we used to we need to find in cutting or machining process. So other parameter is, so I told you initially 3 parameters are very important other than the rake angles. Whatever the geometry of cutting tool, other than geometry of cutting tool, whatever the parameters we are giving during manufacturing or machining processes. First thing is speed. So speed is nothing but, for example, you see here. So this is a typical lathe machine. So whatever your wood cutting, turning lathe, whatever the wood piece you are inserted, so this wood piece is rotating at particular speed, right? So this speed at which your workpiece is rotating is called as the speed of cutting. So speed कैसे calculate करते? So you having one standard diameter of object is there. So how to calculate your speed? कैसे calculate करेंगे speed को? So circular object का speed कैसे calculate करते हैं? आप physics में पढ़े हुए हैं, आपके maths में पढ़े हुए हैं, right? How to calculate in a circular a wheel which is having a diameter of d, right? D mm or d meter. So how to find it is turning a revolutions of 60 turns per second or per minute, right? N. So n value whatever is the turning per minute is 60 revolution is making. For example, आपकी vehicle की speed calculate करना है. कैसे calculate करते हैं? Whether it's a bike or car. So we need to see how many number of rotations your wheel is making in 1 second, or maybe in 1 hour, or in 1 minute. So एक time में how many revolutions are they making? So from that only we are calculating, right? Speed at which your tire is rotating or tire is moving. So number of revolutions. So number of revolutions we can call it as n. And diameter. Diameter is nothing but you need to calculate the circumference. So एक wheel का जो circumference है वो 60 बार revolve हो रहा 1 second में. So then, so whatever the circumference of your tire is there, that you need to multiply with the number of turns. So that will give you the velocity or speed at which your vehicle are moving or your wheel is turning, right? अगर 60 टर्न्स 1 सेकंड में कर रहा है और उसका डायमीटर आके आपको एक 500 हाफ मीटर का डायमीटर है, so how you will calculate the speed of the wheel? Simple, pi d n by 60. So pi d n, pi d is nothing but circumference, pi into diameter of the any circular object. Pi d into n is nothing but number of revolution it's making. If it is n is making for number of revolution per minute, so normally we used to calculate the velocity in terms of second. So n by 60 we need to write. So pi d n by 60. If it is n is given in terms of second, then by 60 is not required. Directly pi d, so the circumference into number of revolutions or number of turns in 1 second. So that will give you the velocity. So velocity of any cutting tool also can possible to calculate the same formula. So pi d n by 60. So pi n. So whatever the n value, this v velocity is nothing but v is how we calculating pi d. D is nothing but diameter of the job. So this is the diameter, right? So this is the diameter. So diameter pi d n. N is nothing but here how many revolutions your workpiece is rotating in 1 minute, right? In 1 minute time, maybe your whatever the wood piece you are inserted in the wood cutting lathe, wood turning lathe, it is rotating something about 60 turns in 1 minute. So you need to write 60 and 60 divided because it's a minute. So velocity we need to calculate in second. So pi d n by 60. So velocity of any cutting process is calculated by this pi d n by 60. If it is a circular object, if it is a length object, we need directly you can take it as the length divided by how much time at which speed that your cutting tool is moving. So just because we are going to calculate for most popular process or more simple process is the turning. So that's why just turning velocity of cutting in turning is calculated by pi d n by 60, right? So this is called as a cutting velocity or nothing but cutting speed. So this whatever the revolution rotation is called as a speed. And next important parameter is considering as a feed. So what is meant by feed? I told you, right? So if it is this is the workpiece, it is rotating. So this is your cutting tool, right? So cutting tool is, so if you're whatever the rotation of your workpiece, this is considering as your speed of the cutting. But feed is nothing but, so not this rotation. So whatever the cutting tool is also is moving parallel to the axis of rotation. So आप maybe आपके wood cutting lathe turning lathe में आप chisel लगा दे के chisel को laterally move करते जाते हैं ना, ऐसा नहीं कि chisel को एक जगह रख दे रहे आप. It has to move it. One thing your workpiece is rotating, which is calling as the speed. At the same time, you need to move your cutting tool at lateral to the axis or parallel to the axis of the rotation. So that lateral movement is called as a feed. So that is calling as the feed. So this feed is very small. So speed is very high. Speed maybe normally we used to give meters per second, but feed we used to give mm per minute or mm per second, right? So speed very small we are giving because once depending upon your thickness of the chisel or thickness of the cutting tool and rotational speed of here this because f is again depending upon the v rotational speed. If this speed is very is slow, then obviously your feed also slow. Because why we be giving feed? So one revolution, one rotation, whatever the workpiece is moving, at that time you're removing the material at this particular location because depending upon your thickness of your cutting tool, only that position you can remove. So now you need to remove the material by side by. So that whatever the thickness of the tool is there, the thickness of the tool you need to move forward. So this movement forward is one revolution of again second revolution. So like this, you need to start moving your cutting tool. Then only you are removing the material from entire surface. So these lateral movement, whatever we are giving, this lateral movement is calling it as a feed. And third thing is the depth of cut, right? So once revolution as it's moving, एक बार आप पूरा move करके लेके गए, यहाँ तक cutting हो गया, एक part हो गया, उसके बाद फिर लेके आ रहे. So लेके आने के बाद when you're keeping the cutting tool, you're not keeping the same point whatever you previously you kept it because already material is removed. Now what you're doing, you're moving this cutting tool little bit more inside. That's maybe 100 micron, 0.1 mm or 0.2 mm or maybe in 0.5 mm. In wood, we can give it 1 mm also, 1 mm or 2 mm also we can give. But in metal, normally we used to give something about 0.1 to 0.2 mm only, not more than that. So whatever the metal penetrating into the workpiece, that is called as a depth of cut. So just now we are seeing, right, in the problem. So depth of cut is given as how much? 0.1514 mm. So that is depth of cut, is nothing but, so how much the tool is penetrating into the workpiece is called as a depth of cut in this lathe. So rotation of the speed, the rotation of your cutting tool is called as a speed. Rotation of parallel movement of cutting tool, so parallel to the axis of the rotation, is called as a feed. And lateral movement, how much into the workpiece it is penetrating, it's called as a depth of cut. So these three parameters also very important when you're calculating power and velocity, or maybe in force of any workpiece when you during the machining. So also for material removal rate at which the material is removing from the workpiece, that also one of the important characteristics or important parameter you need to measure during manufacturing process or machining process. How much material is removing from your workpiece so that you are going to get final object. So unwanted material is removing, that is called as the machining. So at which rate you are removing the material, based on that only you can calculate how much time is required for the machining. So normally our intention what is there? So always we need to manufacture or we need to cut any object in less time, right? That is the main intention of any process. So if you want to have less time, means material removal rate has to be higher. So MRR. So how to calculate material removal rate? So material removal rate, for calculating material removal rate, simple formula. So material removal rate is nothing but feed, depth of cut into velocity. VFD, FDV, whatever. So these three parameters, all these three are the linear parameters, right?
Sir, feed
so
means I don't understand. Sir.
Yes.
Feed.
You not understand feed? Yes.
Yeah.
So please pay attention to my video, not on slides. मेरा वीडियो है, वीडियो को आप उसको कर लो, क्लिक करो वीडियो पे, वीडियो बड़ा हो जाता. तो वीडियो पे देखो. So just assume this is my workpiece. So आपका just याद करिए आप wood turning lathe करे थे ना in workshop में. So this is my wood turning lathe, right? So this is the workpiece. So this is my hands. Assume it my hands are wood turning lathe. So in between my hands, in between jaws, you are holded this workpiece, right? तो वर्कपीस होल्ड करने क्या कर रहे हैं, इसको रोटेट कर रही है, रोटेट हो रहा, जैसे आप मशीन ऑन करते तो इसको ये रोटेट हो रहा है ऐसा, राइट? सो दिस इज रोटेटिंग, राइट? तो जो जिस स्पीड से रोटेट हो रहा, दिस इज कॉल्ड एज ए स्पीड, राइट? ये स्पीड तो क्लियर है ना आपका? स्पीड किसको बोलते हैं? हेलो, आप क्वेश्चन पूछे, मैं इसको आंसर दे रहा हूं, राइट? सो ये एट विच स्पीड इट इज रोटेटिंग, इट इज कंसीडरिंग एज ए स्पीड, राइट? दिस इज स्पीड. किस स्पीड में ये रोटेट हो रहा है, ये वर्कपीस आपका रोटेट हो रहा है, उसको स्पीड बोलते हैं. उसी खाली रोटेट हो तो आपको मशीनिंग नहीं होती, राइट? मटेरियल रिमूवल नहीं होता. उसके साथ में क्या करना पड़ता है, आपको टूल लगाना पड़ता है. ये रोटेट हो रहा है ऐसा, राइट? ये ऐसा रोटेट हो रहा, साथ में आपको यहाँ पर टूल लगा के कट करना पड़ता है, राइट? तो जैसा रोटेट हो रहा, तो जब टूल आप लेके पास में, तो मटेरियल जो एक लेयर ऑफ मटेरियल है वो रिमूव हो रहा, राइट? तो ये जब आप टूल पास में ले जाए तो लेके जाके टूल ऐसी नहीं रख रहे आप, राइट? So you need to do what you used to do. You need to keep moving this tool parallel to your axis of rotation. So this is axis of rotation, right? So as axis of rotation ऐसा rotate हो रहा, उसको parallel में आप ऐसा move कर रहे हैं ना cutting tool को. So ये motion जो parallel motion है, इसको feed बोलते हैं. So this is called as a feed. ये मैं उंगली देख रहे ना मेरा, मैं देखो ऐसा ऊपर लगा रहा हूँ अभी. तो आपको ये दिख रहा ना? So are you able to see me? So are you able to see me? तो यहाँ पर जो है ये मेरा कटिंग टूल है, मेरी उंगली जो है अभी दिख रही, वो कटिंग टूल है, और मैं जो पेन पकड़ा हूँ ये आपका वर्कपीस है. तो वर्कपीस से रोटेट हो रहा, जब रोटेट हो रहा तो आप कटिंग टूल यहाँ लगा के इसको क्या कर रहे हैं, आप इसको ऐसा मूव कर रहे हैं, इसको ऐसा पैरेलल ले जा रहे हैं, जब भी आपको पूरा थ्रू आउट द लेंथ यू विल गेट कटिंग. अदरवाइज यहीं रखे तो खाली यही पोर्शन कट होंगे ना. तो पूरा आपने ये पूरा कट करना है, पूरा इसको पर 20 mm मटेरियल को 10 mm करना है, तो इसको पूरा करना है. So what we need to do, so cutting tool we need to introduce here and we need to move this cutting tool parallel to the axis of rotation. So ये जो किस स्पीड पे मूव कर रहे हैं, मे बी इसको ये बहुत हाई स्पीड पे रोटेट हो रहा, बट इसको हम उतने हाई स्पीड पे रोटेट नहीं कर रहे, मे बी एक मिनट में हम 10 mm मूव कर रहे, बस 1 मिनट हल्लो, क्योंकि ये रोटेट हो रहा ना, हम धीरे इसको ऐसा मूव कर रहे, राइट? तो इसको मे बी how and which speed we are moving, we are moving something about 10 mm per minute we are moving. So this 10 mm per minute movement is called as a feed. So this rotation called as a speed and this whatever the movement is called, this is called as a feed. And similarly एक बार ऑपरेशन होने का या नहीं, उसके बाद मैं फिर इसको थोड़ा और नीचे I will push this tool into this material, right? So this is called as a depth of cut. So these are the three parameters which is very important. So I hope you're clear now about feed.
Yes, sir.
So right, so then the feed, just multiply these three parameters, feed, depth of cut and velocity will give you the final material removal rate. So material removal is nothing but how much material you are removing from the workpiece or from the blank in unit time. That's maybe in per minute or maybe per second. So that is well coming by feed. Normally we calculating per second. Depth of cut is giving only once in a complete operation. It's also mm. Then velocity also in length, meter or mm per minute or per second, right? So if you multiply all these things, this will coming mm cube per second or per minute it will come, right?
ये फीट का फॉर्मूला क्या है?
फीड का फार्मूला क्या है? फीड इज नथिंग बट mm per second. So in 1 second how much feed you are giving, that is called feed, right? कितने 1 सेकंड में और 1 यूनिट टाइम में 1 सेकंड या 1 मिनट में आपका जो कटिंग टूल है कितना मूव हो रहा है यहाँ पर. So इसके ऊपर पैरेलली इसको कितना कैसे मूव हो रहा है, मतलब this nothing but units is nothing but your mm per second or mm per minute, right? So then coming to be wear, there is a wear also happen because there is a high forces, high temperature when involving. There is a possibilities are there. Tool can wear out. So because of that only, periodically you need to grind your tool. That's why we having a cutting tool, cutter grinder is there in our workshop. So there is a 3 different types of wears are possible. Tool get worn out due to the long-term usage. So whatever if you're using continuously, maybe even if you're using diamond tool also, if you continuously using for days together, then definitely after some time your whatever the sharp edges are there, that is going to blunt it. So maybe they're going to wear out. So there is a 3 types of wear is there. So one is called as the flank wear. So it occurs on the relief side of the tool and the side relief angle. So whatever the flank faces are there, I think in previous classes I told you, flank is nothing but the surface of the cutting tool which is directly touching with the workpiece is called as the flank. If any kind of wear is happening in the flank, that's called as the flank wear. And this flank wear is happening in the clearance side, right? Whatever the clearance we're giving, that's why you used to call it as the clearance or relief angle. So then is the crater wear. Crater wear is also called as the face wear. So in chip, on the one face of the cutting tool, one surface of the cutting tool, your chip is flowing. So that portion is called as the face. So when this chip is flowing, there is a possibilities are there. Chip can erode your surface of the workpiece, or maybe not immediately, maybe in hours together. If you're continuously machining, continuously chip is flowing on the cutting tool. So after some few hours or after few days, there is some scratches are happening on the surface, on the face of the cutting tool. So that is called as a crater wear. It occur on the rake face. Rake face is nothing but face of the tool. And notch wear or chipping. So not only surfaces, even your cutting edges or cutting nose, what we used to call as a single point cutting tool. So whatever the cutting nose is there, so cutting nose also can wear out. So that wear is called as a notch wear or chipping. So chipping means it's nothing but in tool, it's called as a tool chipping. It's not a work chipping, it's a tool chipping. So in that, whatever the sharp edge is there, that is wear out. So wearing out sharp edge is called as the chipping or nothing but notch wear. So these 3 basic wears are there. If somebody is asking you, maybe this kind of question may come for the 2 marks, what are the different kinds of wear can be possible in a tool means, you need to write these 3. So flank wear, crater wear, and notch wear are nothing but chipping. So maybe people can take the screenshot of this, then I will go for next topic. So can I give you some time to note down this? This is a 2-mark question. ये बड़े marks में normally नहीं आता, so it's not asking for the 5 marks. Maybe it is a question can expect in 2 marks. So types of wear in cutting tool. So please, I'm giving you 1 minute, 1 second time. Well, maybe I will take.
I have screenshot.
You take a screenshot. That's fine. So please mute your audios. When asking the question, you can answer. Then better if you mute it. So then we can go for next topic. So now our angles are completed. Shear angles, all these things is completed. Now we can move for force and velocity relationship in merchant equation. There is an equation called merchant equation that maybe we can discuss in the next slides. So there is a different kind of force are there in any cutting process, right? So without force, you cannot remove the material. So for removing the material, we need to apply some kind of forces on the workpiece. So then only you can remove, right? Remove the material from that. For anything to displace one position, one place, you need to have a force. So whatever kind of force it is, right? Force is required. So without force, you cannot remove the material. So machining also a removing of material, nothing but cutting of the material. To cutting, we need to apply some kind of force on the workpiece, on the surface of the material, and you need to displace that material from that position, right? So in the class now. So we are discussing about different kind of forces, right? So forces acting on any object. So normally what is there in this? So this, whatever the gray portion is a cutting tool, right? And whatever the red portion is your workpiece. So in that workpiece, whatever this projection is there, so this is nothing but a chip, right? So this portion is a chip, right? So chip is coming out from on this face. So when the chip is flowing on this face, so there is some kind of motion is there. This chip is continuously moving on this surface. So there is some kind of frictional forces acting. Anything, whenever there is a relative motion is there, so there is a possibilities of friction. There is possible friction between the two contacting surfaces, right? That you have seen in your engineering mechanics. So here, when these two faces are meeting, which cutting this whatever the chip is there, chip is touching with the workpiece face. So there is some kind of frictional forces are generating. So these frictional forces, because your cutting chip is moving in this direction, your force is acting a little opposite direction. So whatever F is shown in this on the cutting tool, so this is nothing but frictional force. So F, frictional force F, and whenever the frictional force is there, and this is a contacting with the workpiece, there is a normal reaction also there within the body, right? So this normal reaction we are representing by N, right? F and N, frictional force and frictional reaction. This is nothing but frictional reaction which is generating at 90 degrees to the frictional force. So this is one set of forces, and this set of forces causing some kind of resultant. In your engineering mechanics, you already studied about the resultant forces. When two forces acting on a particular point, so these two forces causing some kind of resultant. So the resultant is giving you the final effect of these two forces on the body. So these two forces we can replace with one single force. Similarly, one single force also we can resolve into the two perpendicular forces, right? So here, whatever the two forces are there, from these two forces, we are finding one resultant. So resultant is R. So maybe you studied in engineering mechanics about parallelogram of laws as well as a sign convention, or nothing but your sign laws to find the resultant of any two or three forces. So here two forces are there. So Fn2 force resultant is R, right? So these are the forces acting in tool, right? So this is called friction force and normal reaction. Similarly, within the material, because there is some kind of deformation is happening. So deformation is happening because of some kind of shear forces. So here in this shear plane, or nothing but whatever the shear angle we discussed from last 1 hour. So in this also you having some kind of forces. So whatever the force is there on the shear plane, this force is called as the shear force. So here you see. So shear force is happening in shear plane. So Fs. Similarly, shear force also having some kind of normal force is acting in the shear plane. So that is perpendicular to your shear plane. So that force is calling it as a Fn. So Fs shear force and Fn is normal force in the shear plane. So this whatever previously we have shown friction force and normal force, normal reaction, this is in cutting tool. And this shear force as well as the normal force is acting in chip in shear plane. So these are the two major forces acting in any workpiece and cutting tool. So these two forces, normally whatever this force also having some resultant, because both are perpendicular to each other. So this perpendicular to each other, maybe we can resolve a resultant stress using parallelogram law of resolution, right? So we are getting an F. So this, whatever the resultant force here, so we used to call it as a R bar, because this we are considering as a R resultant force, and this force is considering as a R bar, because only for our simplicity we are considering R bar. So R and R bar. So always this force, R force. Now we are considering this force is coming, resultant force only acting, and here also only resultant force is acting. So R and R bar. So this R force having a magnitude as well as it having a direction. Similarly, R bar also, because it's a force, it having a magnitude as well as its direction. The force is a vector quantity. So you know every vector quantity used to have a magnitude as well as the direction. So here also you have both in whatever the resultant force acting. So on R as well as R bar, we having a resultant magnitude as well as the resultant direction. So resultant magnitude, some X value, and here Rx is also some X value, that is Rx. We can assuming whatever the magnitude is there, this is R bar. And similarly, what is a magnitude is there is considering R. To maintain an equilibrium, so because every calculations, whenever we're doing every calculation, whether it's in the thermodynamics, whether it's in thermal engineering, whether it's a design of machine member, or whether it's a production. So everywhere when you're solving any problem, always we are assuming states in an equilibrium condition. Equilibrium means at the particular point, it is a stationary, because we are assuming forces are acting. When forces are acting continuously, it's acting at particular point, it's an equilibrium. So it has to be equilibrium, only that condition is happened when both R and R bar, because R and R bar, if you say the direction, so both are quite opposite direction. If both are opposite direction, equilibrium is happening only when both are on the same magnitude. So directions are opposite and magnitude are same. Then only we used to have a equilibrium position. So equilibrium position, we are assuming R as well as R bar is the same magnitude, opposite direction, and also both are collinear. So both are is contacting one particular point. If contacting one particular point, then only it is your condition is equilibrium condition. Otherwise, it's not equilibrium condition. Even if magnitude is same, assume. So one force is acting this direction and one force is acting is this direction. What happened? So in this condition, there is a formation of couple will there. So because this formation of couple, there is some kind of rotation is happening in workpiece R maybe two. So this is not permissible, right? So most permissible things are there. So both having the R and R bar has to be equal magnitude, opposite direction, contacting at particular point. That's called as the collinear, right? So the same thing is there in your next slide. So your resultant forces. So now we are not talking about Fn or maybe Fs, Fn. So whatever the resultant of F and N, frictional force and normal reaction, resultant R, and as well as the vector addition of Fs and Fn, shear force and normal force. So resultant R bar. So force acting on a chip must be balanced. To make the balance, it used to be have an equilibrium. For equilibrium, these three conditions has to be applicable. So R bar must be equal in magnitude. As I told you, it has to be same magnitude. So if it is at 100 kilonewton, this also has to have 100 kilonewton. If R is 100 kilonewton, R bar also has to have 100 kilonewton. And second is, it must be opposite direction. It's not on the same direction. If you take both forces are acting in one direction, 100 plus 100, it is going to be 200. Means it is forcing your workpiece from your jaw. Even it is forcing your cutting tool from your workpiece. So cutting tool may break. So that's why the forces are not in the same direction. Forces are in two are opposite direction. Same magnitude, opposite direction, and must be collinear. So means must be meet at particular point. So same direction, meet particular point means the forces are acting on a straight line. So collinear with R. So R and R bar both are collinear. So these are the three conditions are compulsory to make anything is equilibrium. If these three conditions are not meeting, then your cutting tool or maybe workpiece is not stable. Your cutting tool may break or cutting tool can fly off. This may happen.
Sir.
Yeah.
Sir.
Yes.
Sir, repeat once again three conditions.
So you come, you say, you please listen me first, right? So whatever the forces, whatever the resultant is there, so R and R bar, two resultant forces are here. So this R force is coming because of frictional forces and normal reaction due to the frictional forces. So that resultant is coming as R. And R bar is nothing but shear force. What is the shear force acting in the shear plane? So Fs and Fn. So R bar. So this up to this you are clear, right? R and R bar. So in this, if you take the two things are there. One is workpiece and one is cutting tool, right? So this is assume this is the workpiece and this is the tool. If this is a stationary or this is the equilibrium at particular condition, so whatever the forces are there in the tool and that has to be equal to whatever the forces are there in the workpiece. So R, so whatever the resultant force is there, so this force is coming in the cutting tool, whatever we have seen because of friction and because of normal reaction. Similarly, R bar, so R bar whichever is there, the force is acting inside the workpiece. So machining is happen only when whatever the force acting in the workpiece and as well as whatever the force acting on the tool, both has to have same magnitude. Then only machining can be possible, right? So magnitude of the force. So whatever the force are acting on the cutting tool as well as whatever the force are acting on the workpiece has to have equal, same. So that is the first condition. R bar must be equal in magnitude to R. Means whatever the resultant force acting in the workpiece and whatever the resultant force acting in the tool, it used to have the same equal magnitude. So magnitude is same. That is the first condition. Second condition, both has to have mutually opposite direction. One is acting this direction, then other is acting this direction, right? So one is acting this direction, one other has to be acting in other direction. Then only it has to be equilibrium. If both are acting in the same direction, you see 100 kilonewton this and 100 kilonewton this. What happened when 100 plus 100 both are same direction? Then what happened? You have 200 degrees Newton force acting. Then what happened? Your workpiece will move. It is not a stationary. It's not an equilibrium. For equilibrium condition, both has to be same and both has to be opposite in direction and must be collinear. So both has to be acting in one particular point. So these forces has to meet at particular point. If it's not meeting, for example, it is a parallel, then what happened? So the one force is acting on the workpiece and one force is acting on the tool. Then what happened? There is a formation of couple will take place. So recollect your engineering mechanics. So if forces is in offset to each other, then we used to get some kind of couple. This couple used to rotate the object, that is maybe workpiece or maybe your cutting tool. But in cutting process, both has to have stable, both has to be stationary, right? It's not supposed to be rotate at this particular contact point. Your workpiece is rotating, right? Rotating, but it's not rotating about your contact point. It's rotating about its axis. So at any calculation when we are doing, we are assuming that workpiece is stationary at that particular second, because even though workpiece is rotating, in that fraction of second, we are assuming in that when cutting is happening, workpiece is stationary. So we are assuming workpiece is stationary as well as the cutting tool also stationary. In that condition only we are doing the calculation. Remember this, we are not doing the calculation, the rotational motion. Our calculation is a static calculation. These calculations are not the dynamic calculation. So if you put keeping on continuously this calculation, then dynamic calculations will come. So for time being, whenever you're calculating, we are assuming that workpiece is stationary as well as the tool is stationary. So this is maybe for 0.01 second, whatever things it is stationary, that only we assuming that only, and then we are calculating. That is called equilibrium condition, right? So is it clear now?
Yes, sir.
Yes, sir.
Okay. So now we can go for next slide. So now we can clear with the shear forces as well as the frictional forces, right? Shear force inside the workpiece and the frictional forces inside the cutting tool. So there is one more force will come. Fn, Fn, F suffix S and F suffix N cannot be measured directly in order to measure these forces. Normal, because what happened, this Fn, shear forces as well as the frictional forces coming inside the body, and which is very difficult to measure. So we used to have two more forces are coming now. So in addition to these forces, shear forces, shear force, normal shear force, as well as the frictional force, normal frictional force. In addition to forces, two more stresses are acting in the cutting tool. Those stresses are cutting force. Cutting force is nothing but perpendicular to your whatever the force you are applying by the cutting tool on the workpiece. So cutting force, and perpendicular to the cutting force, there is one thrust force is coming. So FC and FT. If you see here in this workpiece, so your shear force is coming this direction, your frictional force coming in this direction. In the direction of motion, so direction of movement of workpiece, there is one more force is acting. So actually that is the basic cutting force acting on the body. So that is considering as a FC, cutting force. So always when your cutting is happening, because of workpiece is rotating, there is some kind of lateral motion also there, lateral force also acting. So that lateral force is considering as a thrust force. So thrust force always, what happened when we're keeping a cutting force, when you're done in your workpiece, maybe you assume, when you felt also, when you're keeping a chisel in your workpiece, there is some force is always try to keep away your workpiece, right? So to overcome that, we need to apply some kind of force on the cutting tool. So this force, which is try to force the cutting tool away from the workpiece, is called as a thrust force. So that is a thrust force, and whatever the force we are applying by moving this cutting tool along with the workpiece, so that force is considering as a cutting force. So here, if you say in this, so FC, which is parallel to the axis of the tool, just assume this is the axis of the workpiece. So parallel to the axis of the workpiece, whatever the force we are applying is considering as a cutting force, and perpendicular to that one, whatever the force is acting by the machine to drive away the cutting tool is called as a thrust force. So in addition to previously 4 forces, these 2 forces also acting, cutting force as well as a thrust force. And these cutting force and thrust force are very important, because these cutting force and thrust force we can measure. So remaining previously what we discussed 4 forces, we cannot measure directly. So we measure these 2 forces, and relation between these forces with other forces, we're going to calculate the forces of that kind of forces also, friction force as well as the shear force. So these 6 forces are acting in any cutting tool at the contact point, at the tip point. I hope is this clear? Now what we have done in this for force calculation, we need to take all these 6 forces at one particular point. So that particular point, what is there? So this is the particular point. So this point is nothing but your contact point, or nothing but your tip. So cutting tip. So cutting tip, wherever it's touching with the workpiece, just assume here some workpiece is there. I'm not drawing the workpiece and cutting. Only this is a cutting tip, and whatever the things are there, this is maybe chip is there here, and here maybe you have some kind of workpiece, right? So this is a typical workpiece is there. Just assume this is the workpiece. So here just and try to keep all forces inside the workpiece only, instead of tool. Even the tool, whatever the forces are there, that is shifted in the workpiece, right? So this whatever the frictional force is there, that is extended, because it's a vector quantity, right? Vector quantity direction. You can extend this vector up to any location. So we have taken this, whatever the frictional forces in the previous slide we have seen, that we are extended here, Fs. And perpendicular to this one, you having this is the frictional force F, and perpendicular to this one, we used to have some kind of normal reaction. So F and N, we have kept it here. And similarly, at shear force we used to have Fs, right? So this is this, and up perpendicular to that one there is one more force is called Fn. So Fn normal force and Fs is the shear force. So these are two forces we are just taking at this particular point. So in addition to that, just now we have seen there is a cutting force is there. So this is a cutting force. So here it is in the direction of axis parallel to the axis of your workpiece. So assume this is a axis of the workpiece, right? So this whatever the line is the axis of the workpiece. This is parallel to axis of the workpiece. So this is the cutting force, and there is a thrust force is there. So thrust force are acting perpendicular to the cutting force. So the thrust force I kept it here. So these are the 6 forces we are taken at this particular point. So this is required to understand all 6 forces in a workpiece. So because this is nothing but a workpiece, right? Workpiece is this one now. So assume that chip is also not there. Your workpiece is here. So we resolved all the forces into a workpiece. So workpiece, this is the tip point. So at this particular point, we have resolved all the stresses. So now you see the whatever the resultant we previously just discussed. So resultant of shear forces as well as the resultant of frictional forces is same, but only opposite direction. So here also we are seeing the same thing. So whatever the resultant is there, so resultant, this are resultant of both frictional force and normal reaction, as well as your shear force and shear normal reaction. Resultant is same. Similarly, the same resultant applicable for the cutting force and normal reaction also. So R value is same. So resultant of all these two pair of the forces is same, equal. So, but if you know any two of this, so other things you can calculate, right? But if you having this kind of geometry, if it is there, if two values you know, for example, if you know the cutting force and thrust force, if you know, so you can find the resultant. So from this resultant, you can find F, you can find N, you can find Fs, you can find Fn. So directly we cannot measure Fs, shear force, as well as the normal shear force, you cannot measure. Directly we cannot measure frictional force as well as the normal reaction. But directly we can easily to measure the cutting force. So cutting force we measure by the strength of the material, right? The strength of the workpiece material. If you know the strength of the workpiece material, and if you know the cross-sectional area, the strength into cross-sectional area will give you the force. So that will give you the cutting force. So similarly, thrust force is nothing but lateral to that one, right? If whatever the force is acting on the workpiece, that you can measure it using a equipment, you can measure cutting force as well as thrust force, you can measure it. So FC and FT you can measure, and once you know FT to FC, you can calculate R. Once you know the R value resultant, because the resultant for any forces are same, so you can calculate any force in this. You can calculate the frictional force, you can calculate the shear force within the body. So in this, there is a relation is there. So in this, especially when frictional force and normal reaction when coming, so whatever the F by N is there, so F by N is nothing but tan beta or tan some angle. So here we are assuming this angle between F and N. So whatever the angle between F and N, we are taking it as a beta value. So this is nothing but this is opposite side, whatever the F opposite, so beta value. So the normally coefficient of friction is depending upon the frictional force. Frictional force, so I'm quite opposite, I'm telling. So frictional force is depending upon the coefficient of friction. So coefficient of friction, whatever is there, that value, if you're doing the tan inverse, that will give you the friction angle. So whatever the beta is there here, so this beta is nothing but your friction angle. So in this, if you say in this diagram, you used to have a lot of forces, magnitude, as well as a lot of angles also there. So these angles are nothing but your, whatever the angles we just now we are seeing. So a new angle whichever is coming between F and N, so this is coming as beta, right? So normal reaction to the resultant. So this angle is beta, and this beta is nothing but your friction angle. So what are the coefficient of friction? Every mating surfaces, whatever the surfaces both are touching with each other, always there is some kind of friction is there. So this friction is represented by coefficient of friction, right? So tan inverse of this coefficient of friction, we used to call it as the friction angle. So here beta, whatever is there, is nothing but friction angle, right? So here the forces and angles involved in the cutting is drawn here, that have seen the vector based upon determination of the cutting forces. We can now look at the equivalent calculation. So determination means whatever the forces we can calculate, we can measure. So among all the forces, which are the forces easy to find, which are the forces easy to calculate is FC and FT. If you know these two, then other values also come to know through this geometry, right? So this is the formula is given for calculating the friction angle. F by N equal to tan beta, that's equal to coefficient of friction. So just we'll move for next slide. There maybe
Sir,
I can have the.
we will note down.
Yes, tell me. Or you want to draw this? So
No,
same
sir,
diagram.
previous slide.
Yeah, you please note down. I'll go back. You just note down this. This write, if in come in the exam about this force resolution of the forces, if it is in 10 marks, please write in properly. This image is expecting. So draw this image. Just I'm removing these angles, these lines I'm removing. Please note down. Maybe don't take much time. Maybe I'll give you 2 minutes time. In that, maybe you can note down. And this formula also note down. Whatever the formula is given at the base. So this formula also note down. F by n is equal to tan beta. So this is equal to nu. So nu is the coefficient of friction. So beta is nothing but it's a friction angle. So terms are given here. F is shear force, Fn force normal to the shear plane. Alpha is the two rake angle. Theta is the shear angle, and beta is the friction angle. So is mentioned here. You see beta is your shear angle, is nothing but your friction angle. Sorry, friction angle, and alpha, whichever is there. This is the cutting tool. Whatever the angle is there, alpha. So this alpha is equal to this alpha, this angle. So this is alpha, and this is nothing but shear plane angle. This is the theta. So three important angles are there here. So shear angle, rake angle, and friction angle. So normally representing friction angle as a beta, shear angle as theta, and rake angle as alpha. So some books maybe they have different notation, but for this subject, take this as a reference. Again, class is there, so I need to give you a 10 minutes break also after this class to next class. Just in next 1 or 2 slides, I will complete today's lecture. Slide. I'm going for next slide. So please take a screenshot and later you can practice, because these things, whatever the images I'm telling you to practice, please those images you can practice. So this actually, if you see in this particular whatever the resultant, so at this resultant, center of the resultant, if you take at the center and if you draw a circle, so this circle passing through all these important points, all these points is passing through. So this circle is called as the merchant circle or merchant force circle. So in that merchant circle, you having all 6 types of forces, are nothing but 3 pairs of different forces are there. So all the forces contact points are lying on the periphery of the circle. So this circle is called as the merchant circle. So this is a very easy method to calculate the various forces involved in the cutting of the material. So if you know this circle, if you draw this circle, and one resultant is common, resultant is nothing but your diameter of this one. The remaining thing you can draw the line according to a particular point with in terms of angles. Then you're going to get all the forces. So this is the theta, right? And this is alpha, and this is the beta. When this is beta, this is coming to be as beta minus alpha, right? Because 90 degrees, this is 90 degrees, and this is 90 minus beta, and this total angle is 90, and here it's alpha 90 minus beta. So this angle is coming as beta minus alpha. So basic trigonometry, if you apply, you're going to get this is beta minus alpha. So these are the 3 important angles: beta, alpha, and theta. In addition to that, we just to solve this resolution, we used to get this beta minus alpha. Means every 3 triangles, what are the triangles we have? So this is one triangle, and this is one triangle, and this is one triangle. So all these triangles, we need to have at least one angle in that to find the other forces, either through sine resolutions or maybe cos values. So coming to here, I'm just removing cutting tool everything. So just I'll try to show your different kind of forces here. So this is a clear picture. So this circle is called as a merchant circle. So in merchant circle, we'll try to keep all these 6 forces. So this is a frictional force. So this is normal reaction, and this is the shear force. This is a normal to the shear force, normal force to the shear plane, and this is your cutting force, and this is your thrust force. So these are the 6 forces is coming. So in that, if you know one, so means so these two, Ft as well as this cutting force, Fc as well as the thrust force, you can easily measure by using one force sensor. So you can easily measure. In cutting force, you can easily calculate it by, if you know the strength of the material, you can calculate Fc. So FC and FT easily calculatable. And once you find this FC, FT, other forces also you can resolve, and other forces also you can find from this, right? So this is nothing but simple sign conversion. So I'm not going to discuss about derivations. I told you. So we are going directly to going into the formulas. So there is a merchant equation to find the best, because I told you the shear angle is a very important angle, right? So in that we have previously we discussed about in tan inverse also, even in terms of shear angle as well as the friction angle also, we are having one relation. From this equation is called as a merchant equation. So theta is nothing but shear plane angle is equal to 44 plus alpha by 2 minus beta by 2. This is also one of the equation is coming from. That is previously we are resolving the forces, only the two forces we are calculated that depending upon the geometry of cutting tool. So now here the theta value is getting by resolution of the forces. So finally values are coming same. There are here. So here also if alpha values increases, so alpha is nothing but your rake angle and beta is nothing but friction angle. If alpha values increases, your shear plane angle is increasing. So as the shear plane is increasing, your cutting force is decreasing, right? That we discussed. Similarly, if beta values increases, so friction values increases, what happened? So this total value is decreasing. Your theta value is decreasing. As theta values decreases, your force required for the cutting is increases. So you see, as the friction increases, so as this is increases, so this is decreasing. As this is decreasing, force is increasing. So frictional forces or the frictional angle is directly proportional to the force, whatever cutting force, right? So as friction is increases, you know, if more friction, we need to apply more force, right? So beta is directly this equation is called as a merchant equation. So derivation for this course, derivation of merchant equation is not required. It's nothing but if you take from this angles, you're going to get this derivation. So we're not going to discuss about derivation, but this formula you need to remember, merchant formula. So theta, shear plane angle equal to 45 plus alpha by 2 minus beta by 2, where alpha is the rake angle, beta is friction angle. So determine the theta, nothing but friction angle. Assume minimum energy principle applied in the metal cutting so that the deformation process adjusted itself to a minimum energy condition. So actually to calculate this theta, we used to go for energy conditions. It's very complicated formulas are coming. That's why for this course, we are not discussing. Maybe tomorrow, if you're going for MTech in tool design, so at that time, all these derivations, all these things you need to learn. But for here, for metal cutting, for this subject, derivations are not required. So all of the possible angles at which shear deformation can be occur, the work material will select a shear plane angle theta. So this is the shear plane angle theta. Minimize the energy given by the cutting tool or maybe by the machine. So by using the minimum energy principle, we are going to calculate this formula, merchant equation. So that merchant equation theta equal to 45 plus alpha by 2 minus beta by 2. Please remember this. So this is derived by a scientist called Huygens Merchant. That's why this formula is called as the merchant equation, and this circle also given by him. That's why this used to called as a merchant force circle, or some books it's considering as a merchant circle. So merchant's circle. So please remember, this is one of the important question may come. What is merchant circle? Please explain. So in that case, if it is a 2 marks question, just you can write something about the resolution of 6 forces is falling within the circle, that is called as a merchant circle. But if it is a 5 mark question, you need to explain and you need to draw the diagram. If it's a 10 mark questions, you need to explain, you need to draw the diagram, you need to explain the angles also. Even you can mention about this merchant equation, right? So can I go for next slide? Any question?
If T and FC जो आप बोल रहे हो sir, FC is directly straight 90 degree to the cutting tool, sir.
Yes. So directly means direction of cutting. You see, FC is nothing but if you see here. So maybe I will draw. FT is nothing but in the direction of cutting. So you see, this is your cutting tool. You see what I explained to you previously also. Just a minute. I will take a pointer. Right. So this is a pointer. What you seeing? So this is alpha value means your cutting tool is something like this, right? So cutting tool is something like this, and your workpiece is like this, right? ये आपका workpiece है. So this is a shear plane. So your workpiece is something like this, right? Then your chip is coming out in this direction, right? So this is your face, right? And your chip is coming out in this direction, right? ऐसा chip निकल के आ रहा, right? So in this, so this is nothing but your workpiece. Your cutting tool is applying some force in the direction of workpiece, right? This is your cutting tool. Cutting tool is direction में मोरा. इस direction में you are applying some kind of forces, right? So whatever the force you are applying to cut the material, that is called your cutting force. So your cutting force to calculate कर सकते, right? If you know the strength of the material, if you know what is the strength, and you'll know the surface cross-sectional area of the cutting tool, that shear force into cross sectional area, that will give you the force, right? Strength of the material. This material, we assume it is a mild steel. So mild steel used to have some strength. If you know strength of the material and if you know at which area, cross sectional area you are cutting the material, that strength into your force, if you apply, you're going to get strength into that plane direction, plane area, F into A, right? That will give you the force. Small f or nothing but sigma, strength of the material into A, sigma into A will give you the force. So that is nothing but cutting force. So cutting force is nothing but, please remember, when this tool is there, whatever the tool is moving, so tool, whatever the force applying on the workpiece is called as a cutting force. So this tool, whatever the force it's applying, so that is nothing but cutting force. Right? It's clear? Cutting force?
Yes, sir.
And thrust force is nothing but perpendicular to that one. When workpiece is rotating and you're applying some kind of force, some lateral force is acting because of reaction of the workpiece. So that force is considering as a thrust force. The thrust force also we can measure, right? एक तो cutting force आप measure कर सकते हैं by calculating the force strength of the material into the cross sectional area of the workpiece, right? You can measure it. And thrust force also you can measure. How you can measure? यहाँ पर जब cutting force आप apply कर रहे हैं, वहां पर अगर आप एक sensor लगा दिए, so force sensor लगा दिए, तो कितना force act कर रहा है वो sensor से measure कर सकते हैं. So ये दो forces, FC as well as FT, we can measure. And other 6 forces not possible to measure. So for that calculation, we used to have this merchant circle. So this merchant circle help us to find the frictional forces as well as the shear forces during cutting process, right? And also by using the
stationary
merchant
process at a stationary position, no, sir.
Yes, we are assuming it as a stationary. You see, as assuming it as a equilibrium position means assuming it as a stationary position only. आपका जो भी whatever the calculations you are doing in your mechanics of solid, you are calculated when a body is moving about on an inclined plane, what are the forces are coming, and that also what we assumed instantaneously at that particular point, whatever the body is there, we assume it as a stationary. Then only we have calculated the forces. We are not assuming it's moving, even though it is moving at fraction of second. जब भी बॉडी एक मूव हो रही है यहाँ से, फॉर एग्जांपल आप समझिए इट्स मूविंग एट 10 meters per minute स्पीड से मूव हो रही, बट इट्स फ्रैक्शन ऑफ सेकंड, maybe 0.001 second at one particular point, we can assume that it is stationary. तो मतलब वो सेकंड टाइम में देखिएगा तो आप ये जो आपकी बॉडी है, whatever the cutting tool is there, that is stationary at particular time. So we are assuming any calculations, we are doing static calculation, we are not doing dynamic calculation, right? So in that static calculation, we are assuming that your workpiece is stationary, but actually workpiece is not stationary. Your tool is not stationary, right? Is it clear your doubt?
Yes, sir.
So instantaneously हम समझ रहे हो stationary है, but actual देखेंगे तो stationary नहीं है. हम समझ रहे क्योंकि calculations को simple बनाने के लिए हम ये समझ रहे कि at that particular point workpiece is stationary. उसको बोलते हैं ना equilibrium condition. अब पढ़े ना equilibrium condition, mechanics of solid में भी पढ़े, thermodynamics में भी पढ़े, thermal engineering में भी पढ़े. Equilibrium conditions means at particular point we are assuming that system is in equilibrium. System equilibrium कब होता? Then system is stationary. So all calculations, whatever we are doing in any subject, most of the 99% of the calculation, we are assuming that system is in equilibrium. Then only we are calculating. If we assume that system is not equilibrium, then is a lot of difficult calculations will come. That we are not doing, right? Is it clear your doubt? So everybody remember this also, merchant equation. So previously the tan of your shear angle, now only directly shear angle you are calculated by 45 plus alpha by 2 minus beta by 2 by merchant's equation. So depending upon your question, your formula has to be there. So what the merchant equation tell us? To increase the shear plane angle, just now whatever I told you, to increase the shear plane angle, right? To increase the rake angle. If increasing the rake angle, definitely shear plane angle is increasing. And reducing the friction angle also, your shear plane angle is increasing, right? In previously we discussed about the shear plane angle. Whenever the shear plane angle is increases, force applying the force or energy required or power required is decreasing. So these things if you apply there, if you increasing the rake angle, already we have seen, if increasing the rake angle, our force required or power consumption is less. Similarly, if we reduce the friction angle, we can reduce the power consumption. If friction angle is more, we need to apply more force, which is result into a more power is required, right? So this is coming from this formula, simple formula, theta equal to 45 plus alpha by 2 minus beta by 2. So definitely if alpha is increases, theta value increases. If beta is increases, theta value is decreasing, right? So fine. So force calculations, I'm not going in depth about force calculations. So this force calculation directly writing here. So what I will do it, maybe today you done some problems also. So I'm not going further now. I'm stopping here itself, right? So these force resolution, these things we can see in the next class.